We're continuing our work on chapter 13. I don't know if we'll finish it tonight because this chapter is really hard, and there's a lot going on. So we'll see if we can finish. There's still like a ton of exercises in this chapter. Yeah, and just a few more pages. So we'll see if we can finish it tonight, but who knows. So the first thing is we got, I didn't write the exercise number. It's exercise 1316. So we're gonna write these functions, which I think I understand what's gonna happen here is we're gonna convert between these. So it says write functions 2 to 3 and 3 to 2 that convert between the freer monads with 2 and 3 constructors. So I think what they mean here is the 2 constructors here and the 3 constructors for program. So we're just showing an isomorphism between the two. So essentially this one has 2 options. So we're going to have what? Something like this and something like this, I guess. All right, so the type here is a program, and I presume that this is basically the same. So all we have to do is make this is just done. So we may be able to just I think we just wrap it in the other constructor. I think it's just this. Okay. And then this one, what is our type F here? So we're gonna get a freer back. So we need to recursively call this function until we get that. So it's just like oh, but this needs to be a program. I see. That's the tricky part, I guess. So we have, I think bind is the one we need. So, okay. So we're clearly going to create some recursion. And we're gonna have to wrap it in a what? An inster or a bind? I'm not even sure. Probably just inster. Does that even compile? I don't think that's going to be right because you need to return a program. So I feel like this is actually going to probably be a bind. And then in here, we're going to pass X, and then we got to do something here. Why does this not work? Okay, so we need to say inster. And then we got to do something here that does what? I assume that I need to recursively call 2 to 3 on A. And then apply F to A, maybe? Oh yeah, it compiles. So this is just 2 to 3.f. I guess? So F will get applied to some A, and then we'll recursively call this until we hit done. And then I guess you can continue with your binds until you hit done or something. I don't really know how to think about this problem. So I had trouble with this last time because I know that this is something like you're using this to implement a DSL. So that's kind of the recursive nature. But what does this isomorphism mean? I guess you're just taking the statements in this monad instance and just converting them to this monad instance. So you wouldn't really finish this recursion, I guess. You're just converting all of the inner pieces, sort of the nested, I don't know, tree? I'm not sure what the right term is here, but whatever this is, you're going to convert it to a program so that this whole thing ends up being a program at the end. All right, so this one, we got 3 statements now, done, bind, inster. So done. Is probably just pure X. We have our bind function. And we have inster. So this is just F, I think. I kind of want to call that something different. Because these X's are the same. Oh, they're not. Maybe we should call this something different. I don't know. Hello? There we go. Let's call it PA. All right, so we need to convert that bind. So there's a hint here. It says it is useful to follow the same shape of recursion as step, but I have no idea what step is here. I don't know what they're talking about when they say step. I looked back in the code and I don't see step. Oh, wait, I found it. But where's the Haskell version? I don't want to see Scala code. Okay. Let's just see if we can figure it out, I suppose. Viewer account off again, or is it just me? It might just be you. I have no idea. I just started, so there were a few people in here, like 2 or something, but it's generally pretty quiet when I start anyway. Sometimes it picks up towards the end, but hey, how's it going? Okay, so our bind function is gonna have to look like this one. Somehow we're gonna have to convert both bind and inster to impure. So we got, what's PA again? It's a program inster A. This is an A to program inster A. So somehow this is going to be impure. What's the type here? That's what I thought. So is there 2 recursive bits this time? So like this needs to recurse on PA until you hit inster IA maybe? Seriously, what's going on right now? So I think we gotta call 3 to 2 on PA. What's PA's type again? Just program inster A. Huh. I think we want to whip out a little GHCID action. This is a program. I see. Maybe we shouldn't start here. We can start here. So this is going to take an A and produce something. We need to apply F to A and recursively call this thing. So it's going to be probably similar to what we had before. This probably works. No. This has to be a freer. What's F again? A to program. And what's this? I'm confused. I have no idea what I do with this one. What do I do with this PA? What I don't understand is why I don't apply F to this A and then do something like 2, 2, 3. Oh, I think I did the wrong function, didn't I? It's 3 to 2, not 2 to 3. Okay, so that's probably correct on this side. It's this side that's the problem because I need to do something with PA to get me back. Whoops. I need to turn this. Wait. Did I just do the same thing last time? Okay, so we need to actually embed something in here, which I guess means it needs to be. We need like another impure? Or do we need. So this type is A to freer insta A. Inster. How do I embed another one? Is there anything that I see? This Scala code makes no sense to me. So this is not helpful. Does this compile? Weird. So it's like these two things are dependent on each other? How strange. Like if I do this, so first this is making me think that this part is wrong because this compiles, but like yeah, for sure. Here. So we have this done thing, which is basically just, I think, the boring pattern match. For the bind, this is basically what I've called PA and F. And so like when I was looking at this before, it's like in other cases, it's kind of just like you're just passing X through and you're doing something to this K. But somehow we have to convert bind to impure. So maybe we should look at those two. Yeah, so this is the difference, is somehow you need to pull this piece out. Do I just have to explicitly pattern match on the cases where it's like, let me see if I can think about this. So like, what do you mean? Can't you just insert A? It seems to me like I need to pattern match again here. Oh, maybe. So I don't think so though. Oh, that's okay. Yeah, I'm thinking out loud. So it seems to me like for these, I need to get to like because that would work. That would work. But then like if I had like done X here or something. That's just an A. So how do I make an inster A from an A? Oh, I just recursively call this with so it'll be 3 to 2 inster X. No, that's not right. What is this inster thing again? I don't understand. I forget what it is. This needs to be, oh wait, duh. This is just pure X. But why doesn't this work anymore? I don't understand. Why do I have to... Why is this the expected type? I don't understand that. Is it because of the definition of impure and I'm just being silly? So like this is F. But it's not. F is A to program inster B or whatever. So we should apply that to... Like, why do I need another... Maybe I just need to say... I don't understand. Like, they're telling me it's similar to some code in the book, but it's Scala code, and when I look at it, it doesn't really mean anything to me. There's way more dots than I'm expecting, and... I don't know. There's weird names. Stuff gives me a headache. B dot A dot flat map. So as far as I can tell, they're writing the following. Whoops, what did I just delete? If it's return here is A. It's done, I guess. So 3 to 2. A dot match. Case. So B dot A dot flat map. The hell is B? That's that. I don't know what this means. I do not know what this means. I think it's in order to perform the transformation, we separate out the F flat map G and then recurse over it. So somehow we need to add some recursion in here. So we sort of saw that before, right? But we need to add the right recursion, and the recursion I have is not right, apparently. So we need to return one maybe we start here. Because this is kind of the structure that I think we are trying to deal with. In here, it's like ugh, I keep writing the wrong thing. Poorly named functions, I suppose. Yeah, see, like, this is probably gonna suffer from the exact same problem as the other one. Yeah, because it's not really nested. It's just somehow I don't understand this recursion. This chapter is very, very hard for me. Let's see if we can find the answer, because this hurts my head. Maybe I can think about it if I saw the answer. I don't know. I can't think about it right now. No, I did not mean that. Um, these are the Haskell book ones. These aren't Book of Monads. Apparently no one's ever done this before. Well, okay, I'm sure somebody has done it before, but they haven't posted their answers online, so like this one I don't know how to deal with. What's the type of F prime again? These have the exact same type. That's interesting. Yeah, I mean, like, the kind of thing I'm doing here is clearly incorrect because it's basically just that I would need to infinitely unfold this PA term. Oh, your Google's apparently nicer than me. Actually, I know Jonathan too, which is kind of funny. What? Oh, sorry. This is, yeah, somebody's honking outside, so sorry if you can hear that. I have no idea what it is. IA impure FR. Where was impure FR? What? Oh, this should be... How? I don't understand. This can't... I mean... What? Wouldn't this just recurse into infinity for a done? Yeah. How the hell does this work? The take... So this just looks funny here, and I don't understand why it's there, but okay. Alright, so, but these ones are fine. I mean, that's totally fine. It's this one that's the problem. You're gonna have bind PA F or whatever. And we gotta let's do the type thing that we normally do and see if anything interesting comes out. So PA is program inster A. F is A to program inster B. Here, let me move this up. And what do we have at our disposal? We have basically impure, which takes inster a that's not right. Inster a freer b freer. Then we have pure, which takes an a to a freer inster a. Okay. And I think so, like, the question that we have a problem with is like how to construct inster a with what we have, right? What do we put here? We basically need to run the program until it's done. Right? Is that the idea? We need to deal with PA until it ends up being done. So we clearly just need to recursively call that. I mean, we have to. Like, this has to be the case, right? Because if we have a program inster a, the only way we're ever going to turn this into freer is by continually running this until we get there. The thing that's weird to me is that this weird extra embedded freer thing is really throwing me off. Then it doesn't compile. It's so weird. Then it's backwards. This is very strange. The Scala code uses... So, okay, let me write this in here. I don't know. I'm just gonna write this in here, and let's just look at it, because maybe somebody understands. I can't do it here. Step.scala. I don't know. Return. Ugh. There's so much noise. Extends. Free. A. I guess. And we need 3 of these. So we have return, which is clearly done. We have inster, which is a SA, extends free, and then we clearly have bind. What I'm doing is translating the Scala code from the book to here, and bind, and then we're gonna see if we can learn something. That's kind of the idea, because I don't know what we're going to learn yet. So A is free SA F A, guessing this implies B, extends free SB, I think. I think this is right. Let me triple check real quick. Bind S underscore AB A free SA F A free SB. And that's clearly bind. Suspend is clearly inster A. Or inster, excuse me. And then done is that. Okay, cool. So that's the type definition, is the idea. And then this is a function called step, which is the one that the recursion is supposed to be modeled after. So let's see if we can figure this out. Def step free SA equals this is this. I have no idea what this is, but this looks like pattern matching to me. Bind x dot a match See, the thing is that there's literally an infinite loop here. I'm so confused right now. How does this work? And what does this scale code even mean? This is what it looks like. This is what the code looks like. And it says the recursion is similar to this one. So what does this mean? This means like this A, it goes here, right? Like this would be, I don't think this, maybe this isn't valid, but like it's essentially like A, how do you do bind F A bind the hell is X? So it's this F up here. So we do need to deal with this inner bind. So I was thinking about this correctly, but this bothers me. So if it's, oh right, I'm so confused. If we get done, we apply F to B. and recursively call the function. So 322 yeah, pretty much. This is a different function. It's just that they're saying that the recursion is similar to this. So my thought process here is that you know, this is confusing. Yeah, I don't either. I'm so confused. I'm horribly confused right now. I might actually reach out and ask Alejandro this question. He seems very nice. Maybe he can help. But I also have a feeling that I'm not going to be able to do any of the rest of the exercises if I don't understand this. Altered. Yeah, it's. I mean, I don't find it very intuitive. Like this code is not intuitive to me. There's a lot of noise, and I don't understand what they're trying to show me. But they did say it's useful to follow the same shape of recursion as step. So that's kind of why I looked at the code in the first place. But my guess is we're going to do something like so we're going to call the inner one, we call this one first. So we're clearly going to recurse, and we're going to say x bind which f do we call first? B's, the f prime a oh yeah. So yeah, this is a different function. Sorry, that wasn't clear. It's just like the idea here is similar. The recursion, the shape of the recursion is the same. And this compiles. So it's just f Kleisli. So it's x bind f prime Kleisli f. And we need this from control monad, I guess. 6. Okay, and then the only other one we have to deal with is the inster ia f, which I think is trivially dealt with as impure ia f. Wait, no. We have to apply f, so 322.f. My goodness. So is this right? I don't know. It compiles, but I have no idea if it's right. Ow. Yeah, so let's put this one at the bottom for a second, and I'll put some extra type signatures or type annotations, and we'll see if it something comes out of it. So this is F prime. And we'll call this B, right? And F is actually the same, I think. I think it's the same. Yep. And then X all right, so extract an A, and let's put up the definition for Kleisli, which we did yesterday, but I already forget what it is, so. Okay, so let's see. What do we have here? And this actually didn't help me much at all, unfortunately, so I'm going to delete it. These ones are actually pretty trivial as far as I'm concerned. This is the one that's hard. So we have MB. What? How do I have a B to MC? Or maybe these are these A's and A1s different? Or the A1s are different here and here? How do I have a B to MC? That's the only part I don't understand. Don't I need... well, we can look at it. It's right here, basically. It's just the reverse Kleisli arrow for F with K. I guess I could have written KF. What I don't understand is how this is the correct shape. I don't see how I have a B to MC, basically. Because I would need, like, A to MA, A to MA. So, what? Yes, this is on a program. You're right. Sorry. So it's up here. You're right. I didn't actually implement it. Well, it's just bind. It's just bind. Yeah, we're yep. We're pulling one layer away, but then I still don't see how this works. But like I can keep saying I don't see how it works, but I don't know how I'm going to gain the intuition of why it works. If we flip the arrow, does it still work? It doesn't. So like it's not like I have it in the wrong order. Basically, we compose the continuation while traversing on the left X until we arrive at a done. I don't get it. Altern, thank you for the follow. Sorry, I just noticed it, but I do appreciate it. We also had one yesterday. Actually, it was 20 hours ago. I'm not exactly sure what they were watching to follow, but compactness also followed. So they were not watching the stream when that happened. But this does work. I think I'm okay with that part, actually. Like this is the bit where we're running the program, right? Like we're turning our program into impure by getting to done. Like I think, or I guess an inster as well. Like one of these essentially. What I don't understand is just why this works, because to me this F and F, these two Fs have the wrong types. But again, it might be, I might think that just because of this, like these things, right? It says A to program inster A1, so I'm interpreting that as B, but like that can't work, because if I can't have I have to have a, right, the shape is just wrong. It either has to be A's everywhere, or yeah, I don't see this. Where's this? I mean, clearly it's F, but why is it F? F should take A1 to A2 or something, but it does not. Haskell is hard. I mean, it like if I had to guess, it looks right. It compiles, but I don't know why. Try writing the full type. Yeah, we can try. Yeah, there's a few other Haskell streamers, Altern, but they're as far as I know, they're not. Yeah, they must be. They have to be. Anyway, they can't be this. I mean, like by definition, they can't be this. It has to be like B to C or something. It's the only way it would work. Otherwise, the Kleisli arrow just doesn't compose, but I'm confused at why my type checker doesn't figure that out. And it's one of those things where I'm like, well, why? Like, it's probably just a GHC thing, right? Like, it does say A to A1, and here it says A to A1, but clearly that's incorrect, right? Like, it can't be that. If it was, this wouldn't work. Maybe if I do it here, it's smarter? No, it's not. So, like, something is wrong with the type checker. Because, well, okay. Something is wrong with the visualization of GHC ID or something. Yeah, but usually it will give me the right A, right? Like, if it wrote A, then it usually means this A. Maybe if I stick an implicit, or maybe if I stick a for all in front of here, it'll be smarter about it. Let's see. So, let me say this about Altern. There are some other Haskell streamers, so you may be aware of Soding, Tsoding. As far as I know, he's still doing Haskell on Thursdays in the earlier in the day. So I don't know what time zone you're in, but earlier in the day compared to now. And also Jappy, he streams Haskell occasionally. I haven't been watching his streams recently, so just been busy at work. But those are two people I know doing Haskell streams as well. They're different than what I'm doing, but still Haskell if you're interested. All right. So if we stick that there, does anything change? Doesn't look like it. It works here. Yeah, I see. Edward, I'm not sure still how to pronounce his name. I've heard it pronounced Met and Komet, so we'll go with Komet. I've heard that more. I've seen that he streams. Also, Gabriel Gonzalez streams as well. I forget his name, but both of them stream pretty rarely. Like, it works here. We can clearly see the right shape. But it just doesn't show up. It doesn't show up here. And I presume that that's true even if I get rid of this for all. Like, this doesn't matter at all. Oh, maybe I need to save it just to give it a refresh. Oh, we could try that too. That's an interesting idea. So what if we did A, B? I like that idea. Yep, there it is. So just two basically arbitrary. Sorry, I'm pointing with my finger, like that helps. A2, B0, B0A. It's right there. So anyway, so F is clearly A to B, and this is B to C. Right? Anyway, that's a good trick for the holes, but I'm not sure I would have come up with this myself. It's very cool though. Okay. Anyway, yeah. So this is wild and hard, but we got there, I guess. We needed some help, but we got there. Okay, so let's remove step.scala because I don't care about that function at all. Oh, you can actually look at this online. I can commit it real quick if you want to see it. Sorry. I think it would show you if you use typos. I think you could also reconstruct two binds instead. Could you please show whole source? So let me just commit this code and then you can just look at it because it'll probably be easier. So that way I can just pass you a link. I think that'll be a little easier for everyone. Finish exercise 13.16. All right, and then so also I want to say something to Jonathan because he might be interested in this, but I'll leave that open and submit like a issue. GitHub. So first of all, I don't need to type this whole link. I'll just get it from Moobot. So if you put Book of Monads in here, it'll give you the GitHub link at the bottom there. And then you can just go, and we're in chapter 13 in the lib code. So I'll pass this link as well. So that's the code that we just finished. And it's basically what we're doing is showing that there's an isomorphism between these two representations of the freer monad. That's the idea. So, yep. That was hard. We're done with this. I didn't save that code. We'll go back here and we'll continue. So it says the new representation, which is isomorphic to the one with three constructors, is useful for highlighting the relationship between freer and free monads. The freer name suggests that we do not impose any requirements on the instruction data type, whereas the free monad requires a functor. So, in order to bridge the gap and express the freer monad in terms of the free monad, we need a way to build the functor out of thin air. Oh, and yeah, so I actually have a video for that as well. Editor, I think. Yep. So my NeoVim configuration is here with GHCID and stuff. I don't show how to like install NeoVim or anything, or GHCID. Not GHCID, sorry. What is it called? Why am I? Oh, Haskell IDE engine. There we go. I don't show how to install that, but there's also a video there to show some of the functionality. I've changed it since then, but essentially we have some key commands down here that help us out. So we have like my leader is comma, so I have like comma CF. So sorry, this is probably really small. Like comma CF for formatting code, comma GD. Or actually, that's just GD. GY. There's also CA, which is like these code actions and stuff. So rename, this doesn't work anymore for some reason. I don't know why it's broken. Yeah, so there's like a few things in here that are useful. I pretty much use this one and this one a lot. I need to use the go to definition more, but anyway. Hopefully that helps you. If you're on Linux, installing the Haskell IDE engine is pretty fast. Just make sure you only install one version. Yeah, you're welcome. If you install multiple versions, you're going to be like waiting for hours, potentially a day, for it to compile. So like only compile one version. And the instructions provided are good enough to get there. Okay, so let's move this to another file. We don't need rank end types. I don't think we got rid of that for all, right? Yeah. And so we're gonna move this to a different name. So source, what do I have in here? Okay, so we'll just write freer. I don't know why I closed. Oh, well, I guess I have to close for this. And we'll call this freer. And then we can just, I don't have to, I could open it up from another file, but whatever. I think the next one we're going to talk about is Koyoneda, so we'll do that next. So module lib where. And we need to restart this, I think, because we moved a file. Hard. I still find continuations really hard, generally speaking. So, and that's basically just continuations. They're just hard for my brain to think about. In the simplest senses, it's not that bad, but it's just the hard recursive things that can be really tricky. Also altern, yeah. What's up, Chrono? We will get going again. Okay, clacky clackies. Can you how much of the clacky clacky can you actually hear? I got browns, I think. I don't remember. I think they're browns to try and be a little quieter. I was gonna get blues, but apparently they're a lot louder. Where? B to A. FA. All right, so we're gonna have to enable GADTs. And that's actually it, apparently. Okay. Neat. So we can implement the functor. It says Koyoneda F is a functor regardless of which type constructor F you choose to instantiate it with. So instance functor Koyoneda F, where fmap F Koyoneda G X. So G is FB. to B to A. And this is A to B. How do I... Ah, I see. Interesting. You don't touch the FB. Weird. What are we gonna do with this? I don't know yet. So it says, this new function still has C, well, whatever we want to call it, A, I guess, or B in this case, as its, what do they call it? As its source type. Interesting. But the freer monad is now just the result of applying the free monad construction after creating a functor via Koyoneda. So we can write, apparently, this. But we need free, which comes from final? Where's free come from? Here. So final, initial, free, examples, free. Nice. You found the functor. Well, fmap, but yeah. We don't have very cool emotes here, but it is what it is. Free. I probably should spend some time with thinking of better emotes, but I really haven't come up with any. The only one that I like is using Hodor, which is a golden squirrel that's sitting over there, which is sort of a meme that comes out of this channel about point free for the sake of point free, but it has nothing to do with Hodor directly. I tried to attach it to Hodor. Anyway. Okay. So it says the free operational package in Hackage makes use of this correspondence to implement the functionality of the operational package by reusing most of the implementation from free. Of course, dear reader, you should not blindly believe statements about the correspondence between two constructions. You don't... Okay. Neat. So the next one is... The next section is called... I don't know what we're going to need from the other cases, so we'll call it... we're at 13.5. We've done basically a stream per section, I think. This is the 4th time we've done chapter 13, and we're only on about, okay, like 1 1/4 per stream. This chapter is dense. Okay, so one of the advantages of separating descriptions of computations from their actual execution is that you can perform some transformations on the former. I think this section is going to be about free applicatives, which is fun. So it says, consider a simple language to describe manipulations of stacks of integers in which we can either push values onto or pop values off of the top of the stack. Using free, we could define this language in the following manner. Okay, so what is happening? Data I stack F. Don't ask me what the F is for. Functor. Free. Pop. Integer to R. Push. Integer R. Deriving functor. Type I stack equals free I stack F. Okay, we will use derived functor in this case because that's what we have. All right, so then we have to build some smart constructors. I sort of remember this from before. We should also make Moobot happy. So I stack integer. And I think we also get lift F from here, so lift F. Unit. Lift F. Push B. Okay. So this simple language is enough to implement a RPN calculator, which is reverse Polish notation, if you've never heard that. It's a way of writing arithmetic formulas that postpones the operation on the operands. So you can write something like the following. So RPN, reverse Polish notation calculator. My PhD advisor actually used an RPN calculator every day. I was like impressed that he did that. He was an Emacs user, so but he had like a physical calculator. So this is exactly equal to 3 plus 2 times 1 plus 4. Yeah, I think I'm pretty sure he was an Emacs user. It's been I don't remember. I should remember, but I don't. The advantage of RPN is you don't need any parentheses. To evaluate a formula, you create a stack of integers from which an operation pops, then required number of operands, with the result of the operation being pushed back onto the top. When the list of instructions is finished, the top of the stack is taken as the final value. So data RPN instruction number integer plus times evaluate RPN instruction I stack integer. We'll have to see if it actually works. So a number. Oh, this is fun looking. I wasn't expecting this. Push. Okay, so we take the result of adding the two last values, we push that onto the stack, and then we continue. Okay. I can deal with that. And this will be times and times. Oops. Yeah, I think this makes sense to me. Like, get a value, add them together, push that RPN instruction onto the stack, and then continue on. Neat. All right, so all right, how do we get a value from this? That's the next question. So it says exercise 1317. Write an interpreter from iStack to state integer. Use that interpreter to write a function from RPN instruction to integer. Sure. So an interpreter is, if I recall correctly, a natural transformation. So we're going to have like interpret, which is going to take an iStack integer and convert it to a state integer something. Okay, so the altern for reference, the goal here is that you should be able to type comma CA under here, and it should try and go find state, but it does not, unfortunately. So this is kind of one of those things that's a little unfortunate about the current state of Haskell IDE engine, but my understanding is it's getting better. So so we need from I forget where it is, sorry. Somewhere in transformer. What's up with the coloration on this? Does it look terrible, or is it just... Anyway, control monad trans state. Something about the colors looks... Oh, you know what? It's probably just the way it looks on my screen because I put my contrast way up. Hang on. Let me fix my screen. You wouldn't see it. It's just my my contrast is way too high. Oh yeah. let's put that back there. And then let's turn the brightness down to like 75. This is probably better. Oh yeah. Okay, so yeah, you wouldn't see it, but my contrast was way too high, basically. I've been playing this game that really is dark, and so it kind of is nice to have the contrast and the brightness up. All right, so back to what we were doing. Control, but you do get this. So monad, trans, state. So it's kind of nice to have that kind of stuff. And this should be like we want to have I think we want this here. Probably. All right, so are we just do we just pop until pop onto we're certainly not going to be pushing anything. So this just contains a list of integers, essentially. I need to look at a different example. Of this one, probably. Okay. So we're gonna pattern match on the constructors. And basically use our state. Not entirely sure yet. So we should be able to pattern match out our constructors. So pop F. And push X R. Ah, I see. Wait, what? Control T. So we're interpreting from one monad into another. So FSF yeah, Elm's been cool. Yes. We've actually, so I want to finish the Elm in Action book, but I think once I'm done with it, I'm going to probably rewrite what we wrote in Elm in PureScript and then use PureScript moving forward. There's some stuff that it just doesn't do that bothers me. So like it's purposefully the way it is. But it just, I don't think it's going to work for me. Yeah. But Lumi is exactly right. It like depends what you want to do. Okay, this is not bright enough. Need to increase the brightness a tiny bit. Bothering me. Oh, actually, I think it is the contrast. Turn this up to here. That's better. Okay. Sorry about that. Yep. So FSF. So it shouldn't be I stack. It should be I stack F, right? I see. Okay, so I need to write this function and then I can use this fold free thing. So this is really stack integer or I stack F. And then we can work with this. And then we'll write basically interpret. It's really like this one should be called prime and this one should be from stack I stack. Do 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 do. Fold free interpret prime, I think. And let's see if it figures out where this is supposed to come from. Well, we don't want to use that one. We probably want to use ours. So we'll just get this from fold free. Couldn't match. I need to shut the door. Hang on. This is Hodor, by the way. The golden squirrel. Found him in a store and I really enjoyed him. Yep. Lumi's got my back again. Okay. So what's wrong? What's wrong with this now? Oh, fold free requires monad M. But I am in monad M. So what's this complaining about? We're just going from FSF to this one. Oh, and that's A to A, I see. So I need to say R to R. And the same is here. I guess. And then it will be fine. But is this really what I want? I'm not entirely sure. Maybe it is. So we need to write to the state and then return. What does this mean? So we have an integer to R function. I don't know what I'm doing. This feels like so long ago. But what is this one? This isn't. This is initial style. So that's not what we want. We want this style, which is free monad style. So we have our smart constructors. Do we need to write the functor instance? Is that the key here? I don't even use that here. Not clear to me what I'm supposed to be doing. Sorry. This evaluate function makes a lot of sense to me. This interpret function I'm having trouble with. But maybe I should give up on using this fold free thing. But I'm not sure I can. Let's try push first. Maybe push makes more sense. So we should have an integer, which clearly needs to go on the stack, and then we return R, I guess. So we're gonna say probably something like do modify plus plus x. Pure R. But this isn't. Something like that. So altern, if Lumi doesn't, we're gonna have to do it on stream at some point, but I don't know how soon that will happen, so. So it's like push means pop means take the integer and do something with it. But we need the last integer. So do x get and so this should be a list. Is there a pop function? Last. That's not a safe last either, but so I guess we should just check. Wait, how do I do this if I can't get an integer? There's really no way to do it. It's just like we don't have the right types, so it's really just pure last x and we also need to remove that from the state. So I need to put what is it? I think it's just put init so it's like we're gonna split the value, or sorry, we're gonna get the state, the beginning, everything but the last value will go in Can I do this? I don't think I can. I think you can. Okay, so I can't use guard. So what if we do... Okay, so we're gonna do actually break. Well, let's just call it pop. So if you get an empty list, it's gonna return an error. And it's going to say, I don't know, interpret cannot pop an empty list. Oh, well, actually, everything else is the same, isn't it? Oh, sorry. You need to specify a type constraint for R in iStackFR state integer. I guess not. I was expecting that I had to as well, but like if I put integer here, I can't use this fold free function because fold free is not implemented for a non-generic R. And really all we're doing is messing with the stack right now, and the only R that's actually available to us is an integer anyway. Right? I think. Technically that's not true. It can be any R. But the operations that we're messing with only change f. Sorry, only change the integer. So we don't have to really worry too much about what R actually is. Because basically we're only messing with the state, right? The internal integer types. Okay, so anyway, we're doing this, which is going to be like... So if you get an empty list, just fail. Otherwise, you're gonna say init excess last excess, and then we can just do let and then we can put s and do that. I don't really love that I have two functions in here named pop, but apparently it's smart enough to pick the right pop. So I don't have to worry too much there. But again, this is actually an unsafe thing to do because I can't deal with the error, right? Like this needs to be some sort of maybe type if I want to deal with the error. But I cannot because of the type. So it is what it is. Is this right? I don't know. Maybe. All right, so RPN. So instruct does what? So we need to evaluate the instructions then we need to interpret then we need to whatever the function is in state that gets us back the state. I just don't remember what it's called. It's like eval state t or run state or something. We will run the state on an empty list. And return the value? Or do we return the state? I think we return the value. So I think we want a val state, actually. A val state empty list interpret. Except I spelled interpret wrong. Oh. Does it work? I don't know. Let's try it. So we need to make instructions. Sorry. Hang on. I forgot what I called everything. So we need numbers. So we need instruct is a number 2, number 3 plus number 4, number 5 plus times. So 5, 9, 40. Is that how math works? No. But anyway. I'm tired. So RPN 45. Was in the ballpark. But it works. What happens if I put this here? Is it just errors? Doesn't do anything? Aye. That's kind of unfortunate. That's kind of unfortunate, but I don't know what else I could get from it. If it only can return an integer, I either return the result or return the state. No, I can't return this. Yeah, well, I guess I could. But what is the state in this case? It's a list of numbers, so I can't even do that. Right? It would be the state would be 5 and 9. Oh, I'm stupid. Sorry. So it's not really complete because there's still state. Or I did something wrong, one or the other. Return value of the computation. Let's just switch to run state. Which would return, which one comes first? The A, right. So this would be and then this should return 9 with, yeah, and 5. So there's nothing you can do about it, I guess. And then so I suppose what we could do is put this in a do loop and say something like computation not complete, right? So we could say integer like the following, and then do where do I do that though? Do I say I guess I can't really do anything. Oh, yes, I can. I'm stupid. Like, we can do something like this. I mean, it's not the most elegant thing I've ever written in my life, but there's really nothing I can do. If we say either, like, we could write, instead of an error, we could just say like either string that, And then we could say left, computation not complete, right x. Right, like that's not bad. Or RPN instructions don't terminate. Something like that. I don't have to really write a nice thing there, just something. So that's not horrible. This should all compile, so at least it shows the stack, something like that. You could see how many things you would need to add. I don't know. Not the most beautiful thing. I said that already. So then we would just write like RPN and this and wait, what? Oh, wrong way. Not. Or we could flip it, obviously. And then that at least gives you an idea that you need to, like, run something else. I don't know. Because we could put more numbers on the stack, right? We could say plus and then put more numbers on the stack like that. And then you would need to do plus to get them off. So at least this gives you an idea of how to get to an answer. I don't know. In writing pure JavaScript. Yeah. For me, I don't care about the performance. I care about the safety, I guess. So that's fine. And like that stuff will only ever get better. Yeah. Like as PureScript gets better, doesn't that just get better as well? This could be like one of those things that you... Yeah, for me, safety and soundness seem more important. But again, I'm not working on, you know, Google Docs. And I suppose what you could do is like you could audit the JavaScript, right? Like if you really wanted to find, I don't even know how you do this, but you could like performance test the JavaScript that comes out and find the slow parts and replace those, I suppose. Maybe there's something intrinsic about what's being generated that's not optimizable, but I don't know. I'm just thinking out loud. Ah, okay. Well, I guess there's not much we can do about that. Let's flip this because it probably will end up reading a little bit better. I don't think that it really does, but it's fine. Well, maybe, okay, so maybe the goal is you don't take PureScript to JavaScript, you take PureScript to like WASM or something. Would that be the idea? I don't know. If you could target something better, or is that not, is that the point that I'm, yeah, I don't know enough about this stuff, so I've never had to worry about, is my JavaScript not fast enough? Oh, sure, sure. We're far away from that, but I suppose that's like the ultimate goal. Okay, so we wrote an RPM calculator using the free monad. Yeah, so yeah, we did that. At some things. Yeah. So it's like make a better compiler, right? That's the goal. But again, that's not an easy goal. All right, so yeah, I think we finished this exercise. I think this makes sense. The only thing that's a little tricky for me is this piece here. Can we actually get this to trigger? I'm not even sure. I think we would just do like start with a plus or something. Like if we just did plus plus maybe. Yeah, so this interpret cannot pop an empty list is a horrible error message. So we'll just clean up the error message a little bit. So two values must be on the stack to call operations. Is that a better error message? Probably not. We don't know which IR we have, right? I can't pattern match on that IR because it's some function integer to R. I mean, I guess I could pattern match on it because we know that it's could only be plus or times. No, we can't. But I suppose this is pretty neat because all we would really have to do to implement another one is just like add it. So like you can just literally do divide. Again, there's some tricks with divide, but let's not worry about them. Actually, there's a lot of problems with divide. Let's use subtract. Division in Haskell is surprisingly difficult. So we'll keep things whole. And we could literally put that there, and then we would have a subtract function. One minus two is not one. it ends up being 2 minus 1. Wait, what did I just do? I don't know what I just did. Interesting. So if I wanted this, I actually need to do this backwards. If I wanted -1, I would have to do that. Maybe that's exactly the way it's supposed to work, but anyway. Okay. So there's that. What time is it? 9:40. We got a little bit of time. Let's see if we can get to the next exercise and potentially implement it. I'm not sure. So the iStack language is amenable to some optimization. For example, if you pop right after a push, there is no need to actually perform the operation. Instead, we can just thread the value without ever touching the stack. If you pop right after you push, I see. Okay, yeah, basically do nothing. We can implement that optimization as a recursive operation over iStack computations. Okay. Oh, optimize. All numbers are doubles. I mean, isn't that... I thought that was true in JavaScript. Oh, I see. Okay. I was like, wait a second. How does that make it slower? But that's not what you're saying. Pure X. I think this probably ends up looking nicer like that. And this only works if we do this. Yeah. So 4 parentheses, pop K free. Yep. I don't see where we're going with this yet, but okay. Is this just a memoization function? Kind of. Oh, I'm missing a parenthesis there. This is just optimize dot K. All right, so this example also shows us the restrictions we have on inspecting an operation. Whenever an operation produces a value that is passed on to the next computation, like pop, we cannot look further ahead. The reason is that the definition of the next computation depends on that same value. We cannot inspect it beforehand. The previous definition of optimize works around this problem a bit by calling optimize after obtaining the value n in the pop branch. This is not always possible. In some circles, you may hear the expression free monads can be inspected up to the information theoretic limit. Okay, so we're probably going to stop here because this exercise is going to take a long time. So I'm just going to write the exercise and you'll see why. But what I would like to do here is, again, move this into another file. So we're done for sure. So I'm going to move source to RPN with free. So can you guess what the exercise is? Just by that. So we're going to have an RPN with operational. What's up, Warren? Okay, so unfortunately, you are catching us right at the tail end of the stream. So I started a half hour early today, so if that screwed you up, I apologize. And I only have 10 minutes left to finish these exercises, which I don't think that I can do. So we might actually... Oh yeah, that's fine. No worries. Thank you for watching, or even lurking, as it were. So the next thing we need to do is write these with operational style. I should probably write in. RPN in operational. In free. Supposedly I started free applicative, but it disappeared from me. I don't think we actually got to free applicative yet. I think that's going to be next. We got into free functor from Koyoneda, basically. Okay, so we need to just move some stuff around real quick. So we're going to write RPN with free as RPN in free. In free. And then we're going to copy RPN with, nope, move to RPN in operational. I'm just getting set up for next stream, so if you're not particularly interested in watching this, you're welcome to head out, obviously. In operational, RPN in freer. Okay, so yeah, that's what we're gonna do next time. So add up to exercise 13, 18. Actually, one more thing I want to do, and then we'll call it quits. So there was the example we did in Freer, I think. This example. I would like to where is it? Here. Reference a new issue. So, solution to exercise. Um, 1316, is that what it is in my book as well? 1316, yep. 13.16. Which different kinds of monads? Like the freer, that kind of stuff, or just like maybe and either, for example? Do you, sorry, which yes? If you said former or latter, I could have figured that out. Lumi, do you want me to tag you on here? Do you want your name in here? Or no? If you let me know, I'll add it. We'll go into an infinite loop. Very low. Look. Rear. Yeah. Hang on. Um. Thanks to one of my viewers. I think the implementation here we go into an infinite loop, the solution here might be useful. It was a tough one. Okay, so that's probably good. Now, there's a bunch of different styles of these monads. Oh, I shouldn't have done that. Sorry. So I'm not sure I can actually answer that question like easily. The difference between free and freer monad is that a free monad requires a functor. So if we look in here and we look for free, it's not in here, it's in final free. So in a free monad essentially starts like this. You have a data type that's a sum type that basically takes your constructors that you're interested in. I forget exactly, this is like a tic-tac-toe board. So there's like, what's the info of the current position and what's the take position, something like that. Like take a new position. And you have to write a functor instance, and then you can define free like this, and then you can define the functors, the applicatives, and the monad for the free data type, and then you automatically get a monad for your tic-tac-toe type. That's kind of the style here. And a freer monad doesn't have this requirement. So in freer, you have basically a tic-tac-toe where with an info and a take, and there's two different styles. I'll show you this one. So in freer, you have this pure and this impure, and then you basically can define your functor, applicative, and monad using the freer and this inster thing, and then you can just use them to do the things you need to do. So we don't actually the only thing you have to do is like basically define your functor, applicative, and monad in terms of the thing that you're using. I wrote same as before, but I don't know what that means. I should probably clarify what that means at some point. I don't know what that means. Anyway, for operational, you have similar thing. You have the data constructors that are from the freer monad, and then you additionally have a done and a bind. And then you, let's see, what do we do here? Then the implementations for functor, applicative, and monad are all the same, but you have to write them. And you have to write these smart constructors. So it's like you use this take and info function to do stuff. Now, I think it's going to be a lot more useful if I take the reverse Polish notation calculator and write it in all of the styles, and then we just compare and contrast those, because I'm going to write them from beginning to end, and you'll be able to see hopefully see the differences. There's also like a sentence about, there was a sentence in here about free versus freer, which was really helpful. Hang on. Yeah, so it's like, it's an extension of operational style. So like initial style, free is an extension of the initial style, and freer is an extension of the operational style. That's kind of the idea. And the difference between the two is basically like one requires a functor instance and one does not require a functor instance, and you get a monad back. So maybe that's the best way to say it, but I don't have a good drawing program for this, but I think that's the idea. Is like on the left hand side you have well, my left, your right, or whatever. Let's just do it. Let's just do this quickly. How do I use this again? Shift plus. Right, so we have here, which is initial style, and oh geez, that's way too big. Then we have do. Right, and then why can't I click that? So no, wrong one. I can draw a straighter line than that, I swear. I can't. So that's kind of the idea. So it's like this one requires a functor, but you get, oh, it's pretty good. You get in both cases a monad out. Right? So that's kind of like what's going on here. Does that make sense? Sort of? Hopefully it makes sense. I think it's approximately correct anyway. Not exactly sure how to draw the relationship. Oh gosh, this causes so much tearing. So I apologize about that. I'll just not move my mouse anymore. But this is kind of like the shape is like initial informed operational, initial informed free, operational informed freer, and then maybe this can, I don't know exactly the historic relationship between these things, but that's how the book presents it, as like essentially this kind of picture. But when we get to the actual implementation of the reverse Polish notation calculator, maybe I'll try and do it in all of these styles. There's also another style, but I don't exactly remember how that fits in here now. Is it supposed to be initial and final? How does final fit in here again? So there's actually another style which I forgot about, so that fits in here, but I don't remember where. So there's also final style, which is pretty popular in the community as far as I understand. So I need to figure out where this one is. Final style question mark, and I'll save this for now. This sort of monad styles, I don't know, and we'll come back to this at some point, but I don't exactly remember how final fits into this picture. Yeah, okay, so that's it for me.